In this video, we're going to talk about a very important and powerful concept in data structures, circular arrays. So let's imagine our queue looks like this. We added a few items and removed 2 items at the front. Now at this point, the rear pointer is referencing the last item in this array. So next time we want to add a new item, rear is going to go forward and it's going to get outside the boundary of this array. That is why we got this exception in the last video. In this array, we have space for 2 additional items. Why shouldn't we use these spaces? This is way more efficient than resizing this array. If you want to resize this array, we have to allocate some memory that is bigger and then copy all the existing items into that new array. This is where circular arrays come to the rescue. So we want to connect the end of this array to its beginning, so it looks like a circle. Now, technically, there is no circle in memory. All these items are stored sequentially, one after another, but this is just how we visualize it. We visualize this as a circular array. Now, let's see how we can implement a circular array. It's actually very easy. So let's bring the rear back. So currently, rear is 4 because the index of the last item here is 4. So 0, 1, 2, 3, 4, right? Now, next time we want to add a new item, if we increment r by 1, it will end up being 5, but this will get outside the boundary of our array. So we want to map this to 0, so we can insert the new item over here. Let's say 60. Similarly, next time we want to add a new item, instead of working with index 6, we want to work with index 1. So 70 will be stored here. Now we have 5 items in this array, so our array is full. But let's just pause here and think about the relationship between these numbers. Let's not worry about the array getting full. Let's just see what is the relationship between the numbers on the left with the numbers on the right. So if we have 7, this should be mapped to 2. 8 should be mapped to 3. 9 should be mapped to 4. What about 10? Well, we cannot have 5 here because once again, 5 is outside the boundary of our array. So 10 should be mapped to 0. Similarly, 11 should be mapped to 1. Do you see a pattern here? What are the numbers on the right side? These are the remainders of division by 5. So 0, 1, 2, 3, and 4. In other words, if we get the number on the left side and divide it by 5, which is the length of our array, and then get the remainder of the division, that would give us this number on the right side. So here we should use the modulus operator. This will return the remainder of division of left by length. So to implement a circular array, instead of incrementing rear by 1, we should add 1 to it. This will give us the number on the left side, and then we should map it to the number on the right side. So we wrap this in parentheses and get the remainder of division by the length of the array. This is the right formula. So back to our queue class. Let's remove this comment. When we want to add a new item, we add this item at this position, so this is good. Then we need to update the rear pointer. So we set rear to rear plus 1 modulus items dot length. We need to apply the same technique on the front pointer. So instead of incrementing front by 1, we're going to set front to front plus 1. We wrap this in parentheses and then get the remainder of division by items dot length. Now let's see this in action. So back to the main class, this is the code that we wrote in the last video. When we tried to insert 60, we got an exception because this ended up being outside our array. Now let's run our program and see what we get. Take a look. 60 is inserted over here, and we still have space for one more item. So let's add one more item, 70. Now 70 is stored here. This is the funny part. With this circular array, 30 is at the front of our array, but 70 is at the back of our array. So conceptually, our array starts over here, goes all the way to the end, and then goes back to the beginning and finishes here. Now, what if we add one more item? Let's say 80. This time we get an illegal state exception because our array is full. So instead, let's remove an item. q.dequeue. So 30 that used to be at the front is gone. Now our queue or circular array starts from here, goes to the end, and then comes back to here. So we have space for one more item. Let's add that and make sure our code is working. So queue.enqueue 80. There you go. So this is how we can implement queues using circular arrays. Now, so far we haven't implemented the other methods like peek, isEmpty, and isFull. They're super easy. I don't want to waste your time typing what you already know. But if you look at the source code package that you downloaded at the beginning of the course, you can see my solution. Next, we're going to work on another interview question.